Hello friends, and welcome to the Sleepy Brain Science, where the mysteries of the universe guide you into peaceful slumber. Tonight, we journey through the cosmos, exploring the wonders that exist beyond our pale blue dot. Let your mind drift among the stars as we uncover the secrets of space, one soothing revelation at a time. Close your eyes, take a deep breath, and let's begin our gentle voyage through the infinite. Our story begins with the universe itself. Imagine a moment nearly 14 billion years ago, when everything we know existed in a space smaller than a grain of sand. In an instant that defies imagination, the universe burst into existence, expanding faster than the speed of light. This wasn't an explosion in space, but rather an expansion of space itself, carrying matter and energy outward in all directions. Even now, as you rest here, the universe continues to grow, stretching the fabric of reality itself. When you look up at the night sky, you're actually looking back in time. Light travels at an extraordinary speed, yet the universe is so vast that light from distant stars takes years, centuries, even millennia to reach your eyes. The stars you see tonight might have already died, their light only now completing their ancient journey to Earth. You're witnessing the past, a cosmic time machine visible from your backyard. Our own star, the Sun, is remarkable in its ordinariness. It's a middle-aged yellow dwarf, one of hundreds of billions of stars in our galaxy alone. Yet this ordinary star contains nearly all of the mass of our entire solar system. If the Sun were hollow, you could fit over 1 million Earths inside it. Every second, deep in its core, the Sun converts millions of tons of hydrogen into helium through nuclear fusion, releasing the energy that makes life on Earth possible. The Sun's surface is a turbulent ocean of plasma, with temperatures reaching 10,000 degrees. But venture to its core, and you'll find temperatures of 15 million degrees, hot enough to strip atoms of their electrons and fuse them together. The light you see during the day was actually created in the Sun's core tens of thousands of years ago, slowly bouncing through the dense interior before finally escaping into space and reaching Earth in just 8 minutes. Beyond our Sun lies a realm of planets, each a world unto itself. Mercury, the closest planet to the Sun, experiences the most extreme temperature swings in the solar system. During its day, which lasts 58 Earth days, temperatures soar to 800 degrees. But at night, with no atmosphere to hold the heat, it plunges to nearly 300 degrees below zero. A single day on Mercury is actually longer than its year. Venus, our nearest neighbor, is wrapped in clouds of sulfuric acid and has an atmosphere so thick it creates pressures 90 times greater than Earth's. The greenhouse effect has turned Venus into the hottest planet in our solar system, even hotter than Mercury. Its surface temperature is hot enough to melt lead, and its clouds rain acid that evaporates before reaching the ground. Our own Earth is the only place in the universe where we know life exists. 71% water, with a thin blanket of atmosphere protecting it from the harshness of space. From space, Earth appears as a fragile blue marble suspended in the cosmic void. Every human who has ever lived, Every civilization that has risen and fallen, every story ever told, happened on this tiny world. The moon, our constant companion, is slowly drifting away from Earth at about the same rate your fingernails grow. Billions of years ago, the moon was much closer, appearing enormous in the sky and creating tides that would have dwarfed anything we see today. The moon was likely born from a catastrophic collision between early Earth and a Mars-sized object, their combined debris eventually coalescing into our lunar companion. Mars beckons as humanity's next destination. This rusty red world was once much wetter and warmer, with rivers flowing across its surface and possibly even oceans. Ancient riverbeds carved into the Martian landscape tell stories of a world that might have harbored life billions of years ago. Today, Mars is cold and dry, its thin atmosphere unable to protect its surface from cosmic radiation.
Jupiter reigns as the king of planets, a gas giant so massive that all the other planets in our solar system could fit inside it. The Great Red Spot, a storm larger than Earth, has been raging for at least 400 years. Jupiter's powerful gravity acts as a cosmic vacuum cleaner, deflecting asteroids and comets that might otherwise threaten Earth. Without Jupiter's protective presence, life on Earth might have developed very differently, if at all. Saturn's magnificent rings are made of countless chunks of ice and rock, some as small as grains of sand, others as large as mountains. These rings are surprisingly thin, sometimes only 30 feet thick, yet they stretch hundreds of thousands of miles across. The rings might be the remains of a moon that ventured too close to Saturn and was torn apart by the planet's gravity. Or perhaps they're leftover material from the solar system's formation. Uranus rolls on its side as it orbits the Sun, likely knocked over by a massive collision billions of years ago. This sideways spin creates the most extreme seasons in the solar system. Each pole experiences 42 years of continuous sunlight, followed by 42 years of darkness. Imagine a winter night that lasts for decades. Neptune, the windiest planet in our solar system, experiences supersonic winds that race around the planet at over 1,000 miles per hour. This deep blue world is so far from the Sun that it takes 165 Earth years to complete a single orbit. Since its discovery in 1846, Neptune has only recently completed its first full orbit around the Sun. Beyond Neptune lies the Kuiper Belt, a vast ring of icy objects left over from the solar system's formation. Here dwells Pluto, once considered our 9th planet, now recognized as the king of a vast population of icy worlds. Pluto has a heart-shaped glacier larger than Texas, made of frozen nitrogen, and a moon named Charon, so large that the two bodies orbit a point in space between them, dancing together like cosmic partners. Even farther out, at the edge of our Sun's influence, lies the Oort cloud, a spherical shell of icy fragments surrounding our solar system like a cosmic cocoon. This region, which we've never actually observed directly, is thought to be the source of long-period comets. It extends nearly halfway to the nearest star, marking the true boundary of our solar system. Speaking of nearby stars, our closest stellar neighbor is Proxima Centauri, a small red dwarf located just over 4 light-years away. If you could travel at the speed of our fastest spacecraft, it would still take over 70,000 years to reach it. The distances between stars are almost incomprehensible, vast oceans of darkness punctuated by islands of light. Our galaxy, the Milky Way, is a spiral galaxy containing somewhere between 100 and 400 billion stars. From our position about 2/3 of the way from the galactic center, we see our galaxy as a band of light stretching across the night sky. Ancient cultures saw this river of stars and imagined it as milk spilled by gods or a path for souls to travel after death. At the heart of our galaxy lurks a supermassive black hole, a region where gravity is so intense that not even light can escape. This cosmic monster contains the mass of millions of suns, compressed to a region smaller than our solar system. Despite its fearsome nature, this black hole is over 25,000 light-years away, far too distant to pose any threat to Earth. Black holes represent one of the universe's most profound mysteries. They form when massive stars exhaust their fuel and collapse under their own gravity, compressing matter to infinite density at their center. The boundary around a black hole, called the event horizon, marks the point of no return. Cross this threshold, and even light cannot escape. Time itself behaves strangely near black holes, slowing down relative to the outside universe. Neutron stars, the collapsed cores of massive stars, are so dense that a teaspoon of their material would weigh billions of tons on Earth. These stellar remnants spin rapidly, sometimes hundreds of times per second, sweeping beams of radiation across space like cosmic lighthouses. When we detect these pulses, we call them pulsars, and they're so regular they were once thought to be signals from alien civilizations. Stars themselves are born in vast clouds of gas and dust called nebulae. These stellar nurseries are among the most beautiful objects in the universe, glowing in vibrant colors as newborn stars illuminate the gas around them. The Orion Nebula, visible to the naked eye as a fuzzy patch in Orion's sword, is one such nursery, birthing stars just 1,500 light-years from Earth.
Stars live for millions or billions of years, their lifespans determined by their mass. The most massive stars burn bright and die young, exhausting their fuel in just a few million years before exploding as supernovae. These stellar explosions are so powerful they can briefly outshine an entire galaxy, and they're responsible for creating most of the heavy elements in the universe, including the iron in your blood and the calcium in your bones. When a massive star explodes as a supernova, it can outshine its entire galaxy for weeks or months. The shock wave from the explosion ripples through space, compressing nearby gas clouds and triggering new generations of star formation. In this way, death leads to birth, and the cycle of stellar life continues. Some supernovae leave behind expanding shells of glowing gas called supernova remnants. The Crab Nebula, the remains of a supernova observed by Chinese astronomers in 1054, is still expanding today, growing larger year by year. At its center spins a neutron star, the collapsed core of the original star, rotating 30 times per second. Our universe contains structures on scales almost too large to comprehend. Galaxies gather together in groups and clusters, which themselves form superclusters. These superclusters are arranged in vast filaments and sheets, separated by enormous voids where few galaxies exist. This cosmic web is the largest structure in the universe, shaped by dark matter's invisible gravitational influence. Dark matter remains one of the universe's greatest mysteries. This invisible substance doesn't emit, absorb, or reflect light, yet it makes up about 85% of all matter in the universe. We know it exists only through its gravitational effects, watching how it bends light from distant galaxies and holds galaxy clusters together. What dark matter actually is remains unknown. Even more mysterious is dark energy, an unknown force causing the universe's expansion to accelerate. Not only is the universe growing, but it's growing faster all the time. Dark energy makes up about 68% of the universe, yet we have no idea what it is. Together, dark matter and dark energy mean that everything we can see, all the stars and galaxies, all the matter we understand, makes up less than 5% of the universe. The Andromeda Galaxy, our nearest large galactic neighbor, is racing toward the Milky Way at about 250,000 miles per hour. In about 4 billion years, our two galaxies will collide, their stars passing by each other like fireflies in the night as the galaxies merge into a new, larger galaxy. Despite this cosmic collision, individual stars are so far apart that actual stellar collisions will be extremely rare. Throughout the universe, planets orbit distant stars, worlds we call exoplanets. We've discovered thousands of these alien worlds, from scorching hot Jupiters orbiting closer to their stars than Mercury to our Sun, to frozen worlds in the dark outer reaches of their solar systems. Some exoplanets are truly bizarre. There are worlds where it rains glass sideways in supersonic winds, planets so hot that rocks evaporate into the atmosphere, and even planets that orbit two suns, like Tatooine from Star Wars. The diversity of planets in the universe far exceeds what we once imagined possible. Water, essential for life as we know it, is surprisingly common in the universe. It exists as ice on Mars, in the geysers of Saturn's moon Enceladus, and in the subsurface ocean of Jupiter's moon Europa. Comets, often called dirty snowballs, are largely made of ice. Water molecules have even been detected in interstellar space in the vast clouds between stars. Europa, one of Jupiter's moons, may harbor one of the solar system's best chances for life. Beneath its icy crust lies a global ocean containing more water than all of Earth's oceans combined. Tidal forces from Jupiter's gravity keep this ocean liquid, and volcanic vents on the ocean floor might provide energy for life, similar to the deep-sea ecosystems on Earth that thrive in total darkness.
Titan, Saturn's largest moon, is the only moon in our solar system with a substantial atmosphere.
This nitrogen-rich atmosphere is thicker than Earth's, and organic molecules rain down from the sky, forming lakes and seas of liquid methane and ethane. Titan might resemble a frozen version of early Earth, offering clues about how life might begin. The search for extraterrestrial intelligence continues as we listen to the cosmos for signals from other civilizations. Radio telescopes scan the skies, hoping to detect patterns in the cosmic noise that might indicate intelligent origin. So far, we've heard only silence, but the search continues. Given the vastness of the universe and the billions of potentially habitable planets, many scientists believe life must exist elsewhere. The famous Fermi paradox asks a haunting question. If the universe is so vast and old, where is everyone? With billions of stars in our galaxy alone, many of them billions of years older than our sun, why haven't we detected any signs of alien civilizations? Perhaps intelligent life is extremely rare, or perhaps civilizations don't last long enough to make contact, or perhaps we're looking in the wrong way, searching for signals that advanced civilizations have long since abandoned. Space itself is mostly empty, a near-perfect vacuum where the distance between particles can be enormous. Yet this emptiness isn't truly empty. Virtual particles constantly pop into and out of existence, borrowing energy from the vacuum itself for the briefest moments before vanishing again. Quantum mechanics reveals that even the void is alive with activity at the smallest scales. Cosmic rays, high-energy particles from space, constantly bombard Earth from all directions. These particles, accelerated by supernovae, black holes, and other cosmic events, travel at nearly the speed of light. Earth's atmosphere and magnetic field protect us from most cosmic rays, but astronauts in space receive much higher doses of this radiation. The International Space Station orbits Earth every 90 minutes, traveling at 17,500 miles per hour. Astronauts aboard experience 16 sunrises and sunsets every day. Despite being only about 250 miles above Earth's surface, astronauts are in a state of continuous free fall, creating the weightlessness we associate with space. Time behaves strangely in space. According to Einstein's theory of relativity, time moves more slowly in stronger gravitational fields and at higher speeds. GPS satellites must account for these effects, as time passes slightly faster for them than for people on Earth's surface. Without these corrections, GPS would quickly become inaccurate. Gravitational waves, ripples in the fabric of space-time itself, were predicted by Einstein, but not directly detected until 2015. These waves are created by catastrophic cosmic events like colliding black holes or neutron stars. When they pass through Earth, they stretch and squeeze space itself, though by amounts smaller than the width of a proton.
The cosmic microwave background radiation is the afterglow of the Big Bang, light that has been traveling through space for over 13 billion years. This faint microwave radiation fills the entire universe, a baby picture of the cosmos when it was just 380,000 years old. Tiny variations in this radiation reveal the seeds that grew into galaxies, clusters, and the cosmic web.
Quasars are among the brightest objects in the universe, powered by supermassive black holes actively consuming matter. A single quasar can outshine an entire galaxy containing hundreds of billions of stars. Most quasars are billions of light years away, meaning we see them as they were when the universe was young. They offer windows into cosmic history, showing us the universe as it was long ago. Gamma-ray bursts are the most energetic events in the universe since the Big Bang. These intense flashes of gamma radiation can release more energy in a few seconds than the sun will emit in its entire lifetime. They're likely caused by the collapse of massive stars or the collision of neutron stars. Fortunately, known gamma-ray bursts have all occurred in distant galaxies. The universe may be infinite in size, extending forever in all directions, or it might be finite but unbounded, curving back on itself like the surface of a sphere. We can only see a portion of the universe limited by the speed of light and the universe's age. Beyond this cosmic horizon lies forever mystery. Multiple dimensions might exist beyond the three of space and one of time we experience. String theory, one attempt to unify physics, suggests there could be 10 or even 11 dimensions, most of them curled up so small we can't perceive them. These hidden dimensions might be all around us, invisible because they're compressed to sizes far smaller than atoms. Some cosmologists propose that our universe might be just one of countless universes in a vast multiverse. In this scenario, each universe might have different physical laws and constants. Some universes might be lifeless, while others teem with possibilities we can't imagine. We might never be able to prove or disprove the multiverse, as by definition, other universes would be beyond our ability to observe. The observable universe contains at least 2 trillion galaxies, each containing hundreds of billions of stars. The total number of stars in the observable universe exceeds the number of grains of sand on all of Earth's beaches, and each of those stars might host its own family of planets, moons, asteroids, and comets. Yet for its vastness, the universe follows laws we can understand. The same forces that hold atoms together on Earth operate in distant galaxies. The same gravity that makes apples fall guides the orbits of planets around stars billions of light years away. The universe is comprehensible, and that might be its greatest mystery of all. As you drift towards sleep, remember that you are made of star stuff. The atoms in your body were forged in the hearts of dying stars, scattered across space by supernovae, and eventually gathered together on this small world. You are quite literally a way for the cosmos to know itself. The universe is both impossibly vast and intimately connected, from the quantum foam of space-time to the cosmic web of galaxies, from the birth of stars to the mysteries of dark matter, from the Big Bang to the infinite future. It's all part of one magnificent tapestry. Rest now, cosmic traveler. Let the mysteries of space carry you into peaceful dreams. The universe will still be here when you wake, vast and ancient and beautiful, waiting to be explored anew. Sweet dreams from all of us at Sleepy Brain Science.